Let us develop a function that's going to test whether a given number is Armstrong number or not. Let me give you an example of Armstrong number that's going to make the thing easier. 1634 is Armstrong, for example. Now there are 4 digits in this number, you can see that. Now if I go and find out 1 to the power 4, 6 to the power 4, and I need to add them up, plus 3 to the power 4 plus 4 to the power 4, that means each digit of the number 1634 raised to the power 4, that's total number of digits in this number, is going to give us the same value 1634. If this happens, then we say that the number is Armstrong number. Now there is another example, 371, that's also Armstrong. You can just go ahead and calculate this, 3 to the power 3, because there are total 3 digits in this number. So each digit should be raised to the power 3, and 7 to the power 3, 1 to the power 3. If all these are added up, we are going to get 371. So as 370, that's also Armstrong. And from 1 to 9, all are Armstrong, because 1 is 1 digit number and 1 to the power 1 is equals to 1. So from 1 to 9, all are Armstrong. So we need to just write a function that's going to test whether a given number is Armstrong number or not. If it is Armstrong, the function is supposed to return 1 to the caller, otherwise it's going to return 0. Now, first of all, what we need to do is to write another function that's going to get us the total number of digits in the given number. So here is the top-down approach of programming. We need to find out Armstrong number. That's our module. And this module is going to receive n, the number that we are supposed to receive, and it's going to return either of yes or no, that means 1 or 0. Let me just clean this. Okay. Now, in order to find out whether n is Armstrong or not, we need to find out what are the total number of digits in n. So for that purpose, we need to develop another function, say get total digit. That's another module. We are breaking this in 2 modules. So this module is going to find out the number of digits in a number. So n should be supplied to this, and this is going to return the number of digits in n, and that we are going to utilize here in order to find out whether the number is Armstrong or not. So if we supply 371 to this module, it's going to return 3. If we supply 1634, it's going to return 4. So we need to develop 2 functions altogether. Now this is important to realize that how we are breaking down the single problem in sub-problems so that our approach becomes much easier. We can deal individually how to find out total number of digits and how to use that here in order to find out Armstrong number or not. So let's go ahead and write the functions. So let me just declare the prototype of the functions first. It's going to receive integer, and the is Armstrong is going to receive the integer, that's the number we are supposed to test. In both the cases, they are returning integer. Now first of all, write get total digits. I'm declaring a variable count. In order to find out the total number of digits in a number, the logic is pretty simple. We need to go on and divide the number by 10 until we are reaching to 0. Now the number of times we could divide the number by 10 is the number of digits in that number. Let me just give you one example. So we have this number 371. If I divide it by 10 for the first time, that's the division number 1, we get we get 37. Now if we divide 37 by 10 again, I get 3, that's the division number 2. And again, if I go ahead and divide 3 by 10, we get 0, that's the division number 3. Now we reach to 0. So we are done. Altogether there are 3 digits in that number. So this is how we can find out the total number of digits in a number. So I can just go ahead and write a loop here. So while n is greater than 0, we should go on and divide n by 10. And if we can divide n by 10, that means if we can enter in this while loop, then we should increase the counter by 1. And when we come out of this, we just return the total number of digits that's kept in count. So we are done with this. Let me just go ahead and test this, whether this is working fine or not. I'm going to test this individually, and that's another benefit of writing function. You can just go on and test the functions individually. That helps us to find out the bugs more easily, quickly. I know that it's going to return 4 because there are 4 digits. So if I go on and test in this way, it's going to give me 1. If it returns 1, then our test is correct. Otherwise not. Here you can see that it's returning 1. So there are altogether 4 digits. This function returned 4, and we have equalized that with 4, and the equality operator returns true. So the function is working fine. Now let us write the other function, is Armstrong. It's going to receive the number that we are supposed to test. I'm declaring a variable sum. We need to keep the sum of each digit raised to the power total number of digits. Now let me declare a variable count in order to hold the total number of digits in that number, and I'm calling that function get total digits and passing on n. That will get us the total number of digits in the number n. Now we need to go on and execute the while loop. As long as the number is greater than 0, we should continue. Let me declare another variable temp and assign n to temp, because when we will be iterating here in while loop, the value of n is going to be divided by 10 each time, and the value of n is going to be changed. So when we come out of the while loop, we won't have the value for n that was supplied to this function. It will be changed, but we would be requiring that value, the original one that was supplied to this function, for testing with the sum. So I am just temporarily keeping it here in the temp variable, assigning to the temp variable. So let me just do the addition here. So each time I need to find out the digit of that number, and in order to find out that, n%10 is going to get us the next digit, and we can use the pow function to the power count. Since we are using the pow function, we just need to include math.h, because the declaration of the pow function is given there in math.h. Okay. Now each time we should divide n by 10. Let me just go ahead and try run this so that you can understand better what is happening inside the while loop. Say we are given this 371 that I have assigned to temp as well. The value of n is 371, the value of temp is also 371. Now here 371 greater than 0, we are entering to the while loop for the first time. Sum equals to, the value of sum was initially 0. Then what we are doing here, n%10. Now 371%10 is going to get us 1, because that's the remainder. If we divide 371 by 10, it's going to give us 1. Now 1 to the power 3. Now count has been actually initialized with 3. That's the total number of digits here. We have called earlier the function get total digits for that. So here we are getting 1 to the power 3. And then what we are doing, we are dividing n by 10. Now 371 divided by 10 is 37. That's assigned to n. Again we are iterating here, 37 greater than 0, entering to the while loop once more. Now in the second iteration, let me just delete this. In the second iteration, the value of n is 37 mod 10, that gives 7, and the value of count is 3. So pow is going to give us 7 to the power 3, and that's going to add it up with the sum. And then it's actually 37 divided by 10, that's 3, iterating again 3 greater than 0, entering to the while loop. Now in this case, value of n is 3, 3% 10 is equals to 3, and the count is 3, 3 to the power 3 is going to be calculated, and here it is 3 to the power 3. Now the value of n is going to be 0 because 3 divided by 10 is 0, and again when we iterate back to the initial condition, termination condition, the condition is false, 0 greater than 0 is false, we are coming out of the while loop. Now when we come here, we need to test the content of sum with the content of n. Now n has been changed because when we come out of the while loop, the value of n is 0, but we have kept the original value of n in this temp variable, so we should test the content of sum with temp. So here we go. If temp is equals to sum, then it's going to give us 1, so we should return that. If that's not equals to sum, that means if it is different, then the equality operator is going to return 0, so the return statement is going to return 0 if equality fails. Otherwise, if equality is true, the return is going to return 1. So that's how we can write the function is Armstrong. We are done. Now let me test. Let me find out all the Armstrong number in the range, say 1 to 10,000 or 50,000. So I'm declaring a variable I here. Let me go ahead with the for loop. We need to test Armstrong number in the range 1 to 50,000. If I is Armstrong, I'm calling the function is Armstrong. I think I have made a mistake here. Let me just correct the mistake. Yes, there is a spelling mistake. It should be Armstrong. Okay. That was a silly one. So if I is Armstrong, then we should print I %d is Armstrong number. So that's going to print all the Armstrong number in the range 1 to 50,000. Let me go ahead and run the program. Here you can see that these are the list of all the Armstrong numbers in the range 1 to 50,000. 1634 is Armstrong, 371, so as 9474. So that's how we modularize our program and write function in order to make the task simpler, as I have broke down the task in 2 modules, one to find out the total number of digits, and I have utilized that in is Armstrong here. You can see that. So thank you very much.